All right, guys, 8.2, proving triangles similar by AA similarity theorem. Remember that we had these triangle congruency theorems, right? The SSS congruency theorem, SAS congruency theorem, AAS and ASA congruency theorem, and the HL congruency theorem, okay? Also, remember that these three are the ones that don't work for congruency, right? They don't work. Okay, AAA and ASS and SSA. Okay, so you need to remember these are the ones that work for congruency. This is for showing the two triangles are congruent. Okay, now we're going to take a look at some theorems that or postulates that helps us identify two triangles are similar. So these are some shortcuts again. Okay, so the first one we're going to look at is the AA similarity, angle-angle similarity postulate. Okay, here, if two corresponding angles are congruent, then triangle ABC is similar to triangle DEF. Remember the symbol for similar. Okay, let's take a look at an example and see how this works. Okay, here I have these two triangles, and I want to know if they are similar. So here I have triangle ABC, okay, and I have triangle DEC, okay. So let's see if we can match up two angles, right? That way we can show that they are similar. Well, I already have here angle B is congruent to angle D, right? That's given to us, okay? That's given. And I have this angle right here, angle C, okay? So angle C is congruent to angle C. Oops, I messed up. Angle C is congruent to angle C, okay? Because of the reflexive property. Reflexive property of congruency, right? So, let me just fix this. I don't like the way this looks. So let me just fix this because yeah. So angle C is congruent to angle C, reflexive property of congruency. So triangle ABC is similar. So ABC is similar to triangle EDC, EDC by AA similarity theorem, postulate, okay? So it's like the same idea that we did with congruency, okay? So now we're dealing with the sides being proportional, right? The angles are the same, but the sides are proportional. Okay, over here, I'm gonna let you work on this one and do it yourself. So you have to add the angles, subtract from 180 to find the third angle. Here, you have to add these angles, subtract from 180 to find this angle, okay? And then you want to see if these two angles are, if you have two angles that are congruent. If two angles are congruent, then yes, they are similar. If you don't have two congruent angles, then the answer is no, okay? Let's look at C together. Here, these two sides are parallel, okay? That means that I have alternate interior angles right here. Those angles are congruent, okay? And I also have here vertical angles, okay? So the triangles are going to be similar. So yes, triangles are similar by AA similarity postulate, since let's say this, using vertical angles theorem and alternate interior angles theorem. Okay, so that's it for those types of problems. Now On the back, we have like an application, right, of these types of problems that you might see. So we want to find x. X is the height of the tree, okay? So here it's similar to, notice that it's like these triangles right here, one inside the other, okay? But here, I know that this is a 90-degree angle, this is a 90-degree angle, yeah? And then these angles are shared, okay? So I know the triangles are similar by AA similarity theorem, okay? So what I can do here is I can set up a proportion. So x over 6, for example, okay, equals, so now let's see, x is the large, right? So I have to do the large. So remember, we have to add these two. So 12 plus 8 is 20, okay, 20 feet. So the 20 goes on top and the 8 goes on the bottom, okay? I just want to emphasize here that we have this small triangle here, okay? And we have this large triangle here, okay? So the dimensions are 8 and 6 for the small one, yeah? And then 20 and x for the large one. So we set up a proportion. Now all we have to do is do what we did last class. We just cross multiply, right? 8 times x gives me 8x. 6 times 20 gives me 120. Divide both sides by 8. X equals 15 feet. Okay, so the height of the tree is 15 feet.